All right, let's use the quadratic formula to find the roots or zeros or solutions to a quadratic equation. Before we start, we have to check a few things. We have to check that it's actually a quadratic equation that we have here in front of us, and it does have that x squared, so it's looking pretty good. Either it has to equal 0 or it has to equal f of x. Well, we have f of x equals, so we're also good there. And the terms need to be in order so that we don't get confused at a later time. And we do, in fact, have 6x squared, then 11x, and then 1. So we're looking pretty good. Think we're good to move on. So step 1, that's to identify A, B, and C. And we're going to do that by looking at the actual equation that we have here. So I'm going to highlight specifically the A, the B, and the C from that equation. So the A is 6, the B is positive 11, and the C is positive 1. So we've identified all of them. So step 2 then is to substitute A, B, and C into the formula that we have up at the top. So I'm going to write out the formula without the actual letters in there so we can replace them. If I'm looking at the formula, it says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, I made a mistake here. I need to make this a spot that we can actually put a number into. So when I rewrote the formula down here, I still said x equals, but now I left all the blank spots for the numbers a, b, and c. So we're going to actually fill them in based exactly on what we have. We have a b to put in, another b, an a, a c, and an a. So we're going to actually go ahead and do that right now. We're going to put a b where it says b, another b, a is 6, c is 1, a is 6. So we've substituted in A, B, and C into the formula in every single spot that we had for one of the letters. Great. Next up, we need to find the discriminant. Here's the thing. When it says find the discriminant and state the number of real roots, the discriminant is built into the quadratic formula. It is the part under the square root. So really what we're doing is we're just finding out what is 11 squared minus 4 times 6 times 1. I'm going to do it over here. So I'm saying let's do 11 squared minus 4 times 6 times 1, the part under that square root. Let's do that all together as step 3. So we can type it in the calculator or figure it out in any type of way that works for us. If we do, the result will be 97. So step 3 was not only to find the discriminant, it's also to state the number of real roots. If we have a positive discriminant, that means there are 2 real roots. So we are good on step 3. We based it on the discriminant, which again is under that square root from step 2. So we're going to use that when we move to step 4. Let's take a look at step 4. Simplify the expression as applicable. That means we need to look back at this step 2 right here. We're going to need to simplify any part that we can. So for example, negative 11 is looking pretty good. We already did the green part, that was 97. and we have to simplify 2 times 6 as well. So let's actually do that right now. So x equals negative 11, that's that first blue part, plus or minus the square root of 97, we got that from here, all over 12, because 2 times 6 is 12. Step 4 is done. Step 5 is to state the value of each root. So we're pretty much good on this one because we already have everything simplified. Let's just go and say the roots, the solutions, the zeros. The roots are x equals negative 11 plus the square root of 97 all over 12, or x equals negative 11 minus the square root of 97 all over 12, because it said plus or minus. So we had these two options as our final answer. So when we look at the overall problem, remember that we had 5 different steps, but really it's all down to that step 2. Substitute A, B, and C into the formula, simplify it, and then you get your final solutions. So there we are. Congrats.